Okay, so this is going to be a quick glance on how the exponent rules are used in a couple examples. So in this case, we have a whole bunch of exponent rules being applied. The first is we see that there's quantities raised to a power. So that means we want to distribute the power to everything inside. So that's secretly saying -3 to the third, and then x to the third to the third. So -3 to the third is -27, because -3 times -3 times -3 is -27. Here we have a power to a power rule. When we see a power to a power, we multiply the powers. So in this example, we're going to do 3 times 3 is 9. All right, let's look at some more complicated ones where there's even more exponent rules to use in one problem. So we're going to look here. Again, we have terms being to the power, terms being to the power. So first thing we want to do is distribute that power to each part inside the parentheses. Again, to each part inside the parentheses. So 2 to the fourth is 2 times 2, which is 4, times 2, which is 8, times 2 is 16. X squared to the fourth, a power to a power. We do 2 times 4, because a power to a power, you multiply the powers, and you get 8. Then you have y to the third, so third and fourth. So you have a power to a power. 3 times 4 is that exponent for the y. Do it again for the next multiplication section. So 3 to the third, so 3 times 3 is 9, times another 3 is 27. Then you have x to the first up to the third, so 1 times 3 is 3. Then you have x squared to the third. You multiply those powers as well. So you have 2 times 3 is 6. Now you have all of these terms being multiplied together. So all of these terms being multiplied together is 16 times 7. So 16 times 27. I don't have a calculator with me right now, so I'm not going to do that, but you would do the actual calculation. Then you have bases being multiplied. So when you do bases being multiplied, you add the powers of the like bases. So in this case, x and x, we add 8 and 3. So 8 plus 3 is 11. Same with the y's. You have a 12 and a 6. So because the bases are being multiplied, you add the powers. So that's y to the 18th. And again, you're going to type this number into the calculator to actually get it. All right, let's try one more really complicated one that uses a lot of things. So this one uses a couple things, and you can do this in a couple different steps. I'm going to do it this process. So first I see that negative. So remember, the negative power rule switches numerators to denominators and denominators to numerators. So that's the first thing I'm going to do. I'm going to do k to the 4. Oh, remember I just said switch. So why would I write the top as the top again? I don't know. I'm going to write the bottom as the top. Because we took the negative, and then the top as the bottom. Now we have that power rule, so this needs to be distributed to both top people and bottom people. So on the top, we did k2 to the 2, so 2 times 2 is 4. Negative 4 times 2 is -8. 4 times 2 on the bottom is 8. 2 times 2 is 4. Now, we have two like bases being divided. So when like bases are being divided, you take the top number and you subtract the bottom number. So in this case, 4 minus 8 is k to the -4. And here we have the t, which is negative 8 minus 4. So negative 8 minus 4 is negative 12. Again, we can't have any negative exponents. The negative exponents mean that we send these quantities to the denominator. So that means we have nothing left on top. We have k to the 4th on the bottom and t to the 12th. Again, we use those negatives to transport them under it, so that's why the negatives are no longer there. And we box our answer.